I'm going to tell you the story of how assumption met a magic hat. And my name is Olov Lassus, and can you see that all the way back? I hope the text size is good enough. So you'll find me on Twitter as Olov. So I'm going to start up by talking a bit about correct code. So correct code is a great thing, right? Code that works as we intended it to work. That's perfect. That is what we are striving for as programmers. Code that crashes needs improvement. It's clearly not correct unless we intend it to crash. But at least it crashes, so we know that there is an issue with the code, so we can go back and correct it. The real issue is when we have incorrect code that keeps on running. That is a recipe for disaster, I think. I strongly believe it is. And I strongly believe that we sometimes, as programmers, focus too much about creating programs that doesn't crash, while that should never be our main goal. Our main goal should be to produce correct programs. And in the choice of a program that doesn't crash, that keeps on running while it's incorrect, and a program that crashes early, fails fast, so that we know that there's an issue, I always pick that one. So I guess what I'm saying is that crashing is a good thing. We should crash more. We can tell our bosses, crashing, that's a good thing. And fail fast as an idea, that is actually key to making robust programs. Not only fail fast in a robust system, where we have like redundancy and that kind of junk, but also in, the normal day-to-day code we write. Fail fast, I think, is something that makes coding more fun and yields better programs. Of course, it's no silver bullet in itself, right? So another code is that we actually need to write code that works, getting the code right. Not necessarily from the beginning, but we need to iterate on it so that it actually works sometime. But hey, let's admit that we make coding mistakes all the time. And that has nothing to do with whether we have worked with this language that we're now using for a year or two, or we've done it for 2 decades, or whatever. We make coding mistakes all the time of different types. And ironically, we even make a lot of mistakes when we are troubleshooting code. When we are in this kind of debug mode, where we go back to the code base and try to fix things. We do a lot of mistakes then, a lot of mistakes that makes us, that stops us from actually identifying the correct issue, but also that makes us fix the issue in the wrong ways. And the reason for this is because I think it has a lot to do with assumptions. So today's systems are so complex that we need to rely on a lot of abstraction to get things done. And that's when we are using other people's code, and it's also when we're writing code. We need to do it with a lot of abstractions. And we need to rely on a lot of assumptions. So for instance, when it comes to languages, if I use a language that has a programming construct that looks very similar to other languages I've used before, I kind of assume that it works the same. I would be very surprised if an if statement had, a negated condition in a language when I'm used to it working in some ways in more or less every language created before it. It's also the same with libraries, right? So we design libraries and APIs with different patterns. And if we are in Node and someone, and we start using a library that doesn't really follow standard patterns, API patterns of Node modules, we get surprised sometimes. If we model our libraries after other popular libraries like jQuery, but we let them work slightly different, people will get surprised, and it will be hard to do things. So the way I like to think of my brain is that basically it's like a cache, pretty small cache, but fast. So it's an L1 cache or something. And I can only keep so much things in my brain. And again, therefore, I need to rely on a lot of assumptions to get things done. Now, unfortunately, there's often a big disconnect between assumptions and reality, meaning assumptions, what I think the program does, and reality, what the program really does. It might be small, trivial ones like misspelling width and height, which always seem to be a problem, at least when we try to identify the problem, because it's masked by our brains. Off by ones, when we loop one too much or one too little. The different corner cases when we're implementing an algorithm or two, and we don't cover that. We thought that it would be in the general case, but it wasn't. There's a disconnect there. And in design in general. I think the most obvious case on that there actually is such a disconnect and how it's a problem is when we are debugging. When we know that there's an issue in our code, perhaps for some reason, like a core dump or a crash log or whatever it is, we know that there's an issue in this function. It's a function of 10 lines of code or something, and we have taken upon us the task to fix that bug, right? So we take that up in our editor, we put it full screen on the screen, and we just go, line by line, trying to read it out, trying to reason with ourselves what this stuff does. And it should really work, right? I have no idea why it doesn't work, because it should. So if this was C, and it was in like the early 90s or something, then we could blame the compiler, because the compiler was always wrong. JSC had bugs sometimes in code generations. We can always say, hey, it's a compiler mistake. So I guess the analogy for today is that we should blame guys like Eric and Slava and others in the VA team, or whoever, right? Because the VM might be wrong. But often it isn't. Often it's actually our mistakes. We are just not able to find issues in that code, because we already have our assumption of how it works. What you can do then is that you can ask a friend or a colleague or whatever it is, perhaps a friend and a colleague, and ask both of them to come, that person to come sit right next to you, so you could explain the code to him or her. So you start doing that, and you start explaining. So this is the function. It's called blah blah. You know, first of all, I set up my variables here, and I have this and that object. I send it to that module, and I get something back, and then and then you pause, because that's the moment of enlightenment, the silent moment of enlightenment when you realized exactly what the issue was, and your friend didn't have to do anything, because what happened was that you forced yourself to kind of step outside of your own assumptions, because you knew that your friend didn't have the same context of this program like you did. So you had to explain it in more detail, and you have to go and reevaluate those assumptions in your own brain one more time, and that made you fix the bug. How many have, anyone else but than me that have done that sometimes? Many of you, yeah. Does anyone know the technique? It has a name. Oh, all of you knows it. Okay. Perhaps I should just end this talk. You know this already. So rubber duck computing. You have this rubber duck instead. So you can now have your friend and your colleague and your rubber duck, or perhaps in the same, could all of them three be the same? I don't know. You can have them, you can just talk to a rubber duck. Hey duck, I have this issue, and things will solve themselves. Okay, so that's for disconnect. The brain is a beautiful device, right? The beautiful thing. Can you read this? I mean, can you read it, and can you see it, and can you read it? You can't read it. Can you see that it's, you can see this, right? So we can read it. It's according to recent research, the human brain is perfectly able to blah, blah, blah. It's a weird thing, because our brain is so good at pattern matching and at fixing errors. So the trick here is that you fix the first and the last letter in each and every word in a sentence, and you can swap the others around. You need to keep the letters, but you can swap them around, but the brain just fixed it for you. That is exactly why it's hard sometimes to find the width and the height that was misspelled and to fix them, unless we use tooling for it. So the brain tries to be your friend, tries to fix things. So thank you very much, brain. Sometimes that is really, really helpful. At other times, it isn't. And I think this assumption, this rubber duck computing debugging case was another one. Was one of those cases. Why am I saying all this? Well, what I'm getting to is that we should think much more about making our programs easier to reason about. That should be a priority of ours when we start coding and when we, when you design our code and when we maintain it. We talk very much about how to optimize it, how to use very fancy programming constructs, how to use the latest library, the latest framework, the latest language, the latest methodology, Scrum, Lean. XP isn't all the rage these days, it used to be, but now it's TDD still. And we talk so much about all the different technique and stuff we can go and read about and download and use and stuff. But we seem to not communicate that much about kind of other core issues here when we are programming, about the fact that we make mistakes. We make mistakes all the time. If we could reduce those mistakes, we would be much more productive. It might not sound like a super sexy thing to talk about, but it's really, really important. And it's not boring at all either. It actually makes our jobs or our hobbies much more fun, I think. So easier to reason about is increasingly important now, I guess, in this community with JavaScript, because we have JavaScript on the server with Node, and we have it in the browser. And especially in the browser, things have changed dramatically, right? From being small things to apps that are moving all the way to the client. So the apps really scale in terms of size of the code base, but also in terms of size of the teams. When we scale in size of the teams, these things with assumptions becomes even harder, because we need to find a way to communicate them between each other. It's not enough anymore that I have my ideas of how I should write code. We need to communicate it also. So we need to think about stuff like, there's no silver bullet for this. We need to think about stuff like modularizing our code, putting it into different modules, making sure that they have discrete responsibilities so that we can maintain stuff. We need to think about stuff like a style guide if we are on a team. How do we write code and why do we do it? If you missed Angus' talk yesterday, it was an awesome talk. I think the most important takeaway from that was that we shouldn't listen to gospel. We shouldn't just take gospel as truth, because there's so much gospel in the world, right, in programming, from both sides, from all sides. But we should take informed decisions. And we are adults. So we should allow ourselves to take whatever decisions we feel are right for us and for our teams. But at least they need to be informed. We need to understand the trade-offs there, because there is always a trade-off. So you give something by using, for instance, a language construct with, or whatever it is, and you lose something by doing that, perhaps. So that's just some of the things. And I'm going to talk more specifically about subsetting a language for this. But before that, I'm going to talk about Assert. How many here have used Assert, or are using Assert in their JS? Awesome. How many are using Asserts for something that isn't in their test suite, but in their normal code? OK, quite a few, but not that many. That's what I want to talk about. Using Assert, but not in your test suite, but in your code directly. That is how we actually started out using Assert when we created this programming construct, not for JavaScript, but for other languages. That's where we were using Assert, not in our test suites. So the idea of Assert is basically, it's a statement, and you feed it an expression. The expression is an assumption. So you say, hey, I assert this. This is my assumption. This needs to be true, and if it isn't, then the following code, can. I have no idea what it does in that case. I can take no responsibilities for that, boss. So this needs to be true. And it's a way of documenting that, codifying that assumption, but getting it verified. Because once it runs, what happens is that Assert just checks this expression, and if it's truthy, nothing happens. The program just continues. But if it's falsy, then the program crashes. And crashes fast, instantly. It crashes directly there, and it gives you the information you need. Because not only does it crash in a real Assert implementation, but it also prints out your log or whatever it is, the stringified representation of your expression, together with a function, line, and file name. So you can easily see from the log where things went wrong. So what happens is that we can document and verify our assumptions, and we can now fail faster. This is very powerful and very easy to use. So here are just three. You can see those 3 examples, how you can use them, for instance. We can assert that an object state is free. So perhaps I made a custom allocator or like an object pool or something. I now pick this object as candidate for giving out to someone, like a cached new or something. But before that, I just want to verify that it's actually tagged as free, because otherwise I will now start writing over something else. So it's a way of just protecting me from what I know should be the case. But since I'm only 99% sure that the code currently works that way, I actually document it for me and for others in the future. We can also do other stuff in JS, like assert arguments length triple equals 2. That sounds pretty stupid, I think, to many. Why would you assert on your arguments length? That's like user input and everything. Well, first of all, this isn't in a public API. There's this huge. You can search more about that on the web, about using assert in that. We're not talking about the search now. I'm talking about internal APIs. But for instance, when I do refactoring in JS, so when I change the arity of a function in JS from like 2 to 3, or from 3 to 2 arguments, most of the time when I do that, I'm pretty confident that I cache all the call sites, that I update them too. But sometimes I'm not 100% confident that I do that, and I'm not 100% confident that my tests actually catches that. In that case, I just drop in an assert there. It costs me like 5 seconds to write it, and I keep it until I do the next commit, because if one call site, now when I run all the tests and when I try the program out, if one call site actually accidentally was not updated, then assert will fire immediately, and I can just remove it. It's very cheap. The last assert example is just, type of cost. It should be a number, and by the way, it should be a real number. It shouldn't be infinity, neither the positive or the negative one, and it should certainly not be a nan. And if you got a nan in your program, by the way, in JS, that's more or less always a sign that that your code is incorrect. Rarely do we write code where we actually do get nan, and that's the intended result. It's more or less always that we have like user data or something that we didn't sanitize enough, or just another coding mistake. So that's how assert works. We can use it in JS. We can use it with a stringified representation. So there's a link there. I'm going to post the slides later for an example of how you can use a framework I created to actually do real asserts in JS. What it gives us is that it makes the code easy to reason about, because now we have codified our assumptions. It's there for me, like in an hour when I forgot what I wrote, or for me a month from now when I really forgot what I wrote, or for my team members to read and understand my assumptions. It's really powerful. The code becomes more robust because it fails fast. just like you want it, because we certainly don't want code that just keep on running. It very much so simplifies refactoring and code changes, because now I am confident in the code. I'm confident that thanks to all these asserts, together with my test suite, when I do stuff, when I change stuff internally in my APIs, if I do things incorrectly, then the asserts will fire, most likely. Overall, it gives us more confidence. I think it invites us to do more changes to the code, while sometimes when we feel that the code is a bit fragile, we're afraid of that. As a side effect, which I realized very recently after getting it pointed out to me, it sometimes actually makes it easier to write our unit tests too. Because if we go really far and do very assert-rich programming, includes a lot of assertions in our code, then our unit tests focus more about providing input to the functions and seeing, if the function doesn't crash, then it could be okay. So it's not that extreme, but some of our tests can become easier. And it doesn't slow you down. Trust me, if you haven't tried using assert this way, it never slows you down. It speeds you up, because writing asserts takes very little time. If you don't write it, I can assure you that when you read the code, when you write a code, you're anyways going to have that conversation with yourself. What is the code really doing? Well, I think it's doing that. You're going to do that, over and over again, and your colleagues have no clue what your assumption was. So it speeds you up. Other assumption jammers in JS, every language has its awesome parts and its, less awesome parts. It's no different there. Here are some assumption jammers for me, something that increases the disconnect gap for me. Undefined and null, we have 2 of them, which complicate things a bit. The box types, which doesn't play at all nicely with the primitive types, so we therefore mostly don't use them. The function scope versus the block scope, we all know about that. It's an assumption jammer for many, especially those new to the language, but it can actually be an assumption jammer for those who have worked with it for many years too. Surprises me once in a while, still. The global pollution is more or less a fixed problem with ES5 strict mode. The falsy values, we have so many of them. Why do we have that? But we just have so many falsy values. It's a bit more complicated to have them in our heads. The keep on running design of JS in general, it's very much keep on running or keep on tracking. That's how it's designed. So it's not designed to fail fast. It's opposite of it. I was thinking about saying that it's the not equals to fail fast, but then I realized that I might put in the coercing operator, so it might still be the same thing. So, but keep on running. And then you can mix strings and numbers in arithmetic operation. That's a huge assumption jammer in JS. Not only can you do that, but you can actually mix any type and any type in your arithmetic operations. Actually, in more or less any operation you can use any type. And that's what I'm going to talk a bit more about now. Plus is the ultimate keep on running thing in JS. So plus, exactly like our brain before in the example, with the swapped characters that we piped into the brain as a stream, plus says, let me fix that for you. I think I know what you mean. You gave me a null and you gave me an undefined, but hey, I know what you mean. You want to have a nan. Seldom do you want to have a nan. I mean, nans should be more or less prohibited in the language. They are more or less always the result of a coding mistake. But it is what it is, right? And we have learned to live with this. And some of us say that, hey, it's so expressive. The plus is so expressive, and so is minus, by the way. It's very expressive. I can do anything with it. I would like to see that anything, because I think that it's just more error-prone. While there are so many dynamic, beautiful parts of JS that really helps us do really expressive stuff, and I think, again, in Angus's presentation yesterday, like with, you can actually do more expressive stuff by using it, but there are drawbacks to it too. Plus and other operators, are very not failing fast, but keep on running, but they don't give us much in return. And for science, meine Ausdrucksweise. Was that correct? It should be part of my French. I hope it was. But weak typing in a dynamically typed language is not very helpful at all. It just isn't. And I think we need to think about that too in the JS community. I think we need to talk about that. And I think we need to talk about that is a very rare thing. Very, very few other dynamically typed languages share this property of ours. And we need to think about that. So look at Ruby or Python or most of the Lisps, at least after the 60s. Look at the popular Clojure, for instance. More or less all of them are, so it's not a binary, an extreme, whether you're weak or strong, but they are very much so stronger typed than JS. So weak typing in this context basically means that if you take an operator, like a binary operator taking 2 operands, in a weakly typed language, they will try to do something with the types, type convert them implicitly what we call type coercions in the JS to do something good with it, exactly as JS Plus tries to do. And I argued that that is the wrong thing to do. It doesn't help us at all. In the plus case, can you read this? In the plus case, A plus B, what it does is that, first of all, it converts A and B to primitives. So primitives in JS, then we have undefined, null, a boolean, a number, or a string. That's what we get now. It does so by calling a value of and then a to string. It calls a to string unless a value of return the primitive. So if you return an object from that, why you should do that, it's going to call it to string too. Unless a is a date, because date are so peculiar in JS that we actually deeply embedded those in the semantics of the language. So if it's a date, then we're going to do it in opposite direction, opposite order. And then if at least one of them is a string, then we convert the other to a string and we concatenate them. And if otherwise, we convert both to numbers and we add them. And I must admit that first time I realized this coming to JS, my head exploded. My head exploded when I realized that under the hood, when I perform the plus operator, JS might do a string to number conversion implicitly for me, because that was unheard of for me from all of the other languages I worked with. And I thought, that can't be very helpful at all. That gives the illusion that you can mix strings and numbers and produce meaningful results, while you can't. You can't do that in any kind of larger scale. There's the double equals and triple equals thing, right? Again, Angus talked about that. And so my position on that is that I prefer triple equals because I understand the semantics easily, and I can tell that to you now, while double equals is more complicated. I think there's exactly one use case for double equals, and it's safe. Angus talked about that too. It's double equals null. If you really think that it's important to say double equals null, and by that meaning equal to null or undefined, and you prefer the short notation instead of creating a function or something for it, then by all means do that. We can statically verify that you're actually just doing double equals null, and that's safe. For others, I personally prefer triple equals. It's yours to keep. My question is, where is my triple plus? Has anyone seen it? I found a double plus, but that didn't really do what I intended it to do. So where is my triple plus? And you know what? When I searched for it, I found this whole magic hat full of surprises in JS. So on the top row, I found the comparison operators, and then the arithmetics, and then the bitwise, and the shifts, the unit minus, and the increment decrement. Wow, there's so many surprises in there because they accepted anything I gave them, and they gave me something in return that was mostly not useful unless the input was useful. So my question then was, what if we could restrict the hat to something less surprising? Could we ask it to do what we wanted to do and nothing more? Here's my suggestion. Let's take the first row, and let's say that for ordering, for comparison operators, they accept strings or number, but never a mix. So a number less than a number, we know what that's supposed to do, number comparison, and a string less than a string. You check lexical ordering, right? That is everything that makes sense. We don't need to accept anything else, so if we give it a mix, a string and a number, or if we give them a null and something, or an undefined or something, then we just crash. We fail fast because we know that we have an issue now in our program. For plus, we lax a bit more. We give it a string or a number in any combination. Why is that? Why can't we say number plus number is addition, string plus string is string concatenation? Well, because you often do string plus number, and by that you mean convert the number to string and then concatenate them. So let's allow that still. For everything else, numbers. That's it. Why would you ever want to do anything other than numbers on these guys? It doesn't make any sense. So for all those, and for the bitwise operators and the shifts and the increment, decrement, just do it with numbers. How would we do that? Well, we would, instead of writing var x1 equals 1 plus y, we would say x2 equals dunder add 1 comma y. And we would create dunder add with 2 assertions and then returning a plus. So that would be slightly inconvenient, right? Because now we have to rewrite our entire programs. So perhaps we can change plus after all. And here is when I try to do a demo. Can you see this? Is it visible? Yes. Hallelujah. OK. So let's create an average function. So for now, let's just say that we have some kind of translated version to the right, even though it's going to average. What is happening to my average? X and Y. OK. So average, that should be return X plus Y divided by 2, huh? There we go. Oh, it looks the same. Okay, so it's some kind of translation going on, but it seems to be the same for now. Doesn't matter. Let's print something to the console in the below. Let's print average of 1 and 2. What is that? Anyone? 1.5. Let's do it. Yay! Woo! Go JS. 1.5. Okay. Really? 1.5? Okay. Good. Let's try it with something else. Let's try it with 2. In JS, we can mix strings and numbers freely, and JS actually fixes that for us. So the average of 1 in string 2 is also it's 6. So here's just the realization. We cannot mix strings and numbers freely. We always need to know whether a variable is a string or number. And if we fool ourselves into thinking something else, that's a recipe for disaster. We don't want to do that. So it's 6. Why is it 6? Because you take number 1 plus string 2. What happens? You have a string conversion. Number 1 becomes string num1. You concatenate them into the string 12. String 12 divided by number 2. Then you do the implicit string to number conversion. So you get a number 12 divided by 2, and then you get a 6. Other cases that are really common in JS is like we have this variable that we forgot to initialize, like x, for instance. So say that we didn't initialize it, we got an undefined from a function, or we are looking at a object property that doesn't exist. We get an undefined, and when we do that, we get nan. We get this useless nan that doesn't help us from everything. We would prefer to have a crash, right? So here's how I crash this. So instead, let's just add a directive here. Let's say use restrict. How many have used ES5 strict mode? Okay, use restrict works similarly. You can add a directive to your top of your program or to parts of your program to function. Now you see what happened. The translator replaced plus and division to these function calls, the dunder calls that has the type assertion. If we now run this with undefined, we're going to get, bam, restrict mode plus called with number and undefined. You get an exception thrown, and you're going to get precise information about line and everything. If you do it with a 2, the string 2, same thing. You're going to get an exception, and you're going to get an error. And you're going to be aware of the error. In this case, you actually don't get exception on the plus, because in restrict mode, we actually allowed a number plus string, because you would like to do that. But we got it on the division. A string divided by a number, that's not allowed. So that's how we can try to fix this. So the idea of restrict mode then is to say, I promise to limit myself to the subset. I use a checker that translates my code and inserts this type assertion in my program. And of course, I then execute the checked version while I'm developing. I still keep my tests. This is no replacement for tests. Whenever I break the subset promise, the program fails fast. So I'm informed of the issue, and I can correct my program. And the beautiful thing is that all the semantics I described to you, that's a subset of the existing semantics in the language today. So we don't add anything. We just remove parts, which means that once our program is correct, we can just deploy the original program. You don't need to deploy the translator one. It executes identically in restrict mode and normal mode JS. What do we gain? The program is easier to reason about now, because when I read source code that has to use restrict directive, I have an easier understanding it. I know more about semantics. I know more about the meaning of the program, just like Assert. It's the same thing. And whenever I need to fix bugs in it, the assumption versus reality disconnect just became a lot smaller. I know now for a fact that we can't get a nan out of that. Unless we fed a nan into the plus operator, we can't get a nan out of it, for instance. So my program becomes more robust. Is this the right subset? I mean, anyone could create a subset, right? So I guess the way to evaluate it is that it can't get in the way. We need to be able to write our programs like we would like to do, and it should work. And apply it to existing projects, the subset mismatch should be tiny. So just very, very briefly now, but I try to just take a big piece of code, take that, slap the use restrict directive on top of it, run everything to the translator, and then execute the test suite for the program, just to see how many errors do we get. And this is in code that actually works. So the errors should be indicative of a subset mismatch. Somebody wanted to do things that is not allowed to in restrict mode. In v8bench, no big mismatch whatsoever. I had to change a handful of lines. It found a bad practice. In Kraken, yeah, works fine. It catches the old nan bug. The undefined plus something would produce a nan. In jQuery, great match too, and actually found a bug, which we fixed. In JSLint, very, very good match too. Found a debatable practice. I said a bad practice, but then we didn't agree on it. So it's the debatable practice. So from this experience, yeah, finding issues was very unexpected. This is kind of driven under the hood by a framework called JSShaper, a source-to-source rewriting engine. that I created a year and a half ago. It's on JSShaper.org. It's MIT license. You can download it and play with it. It runs in Node. You can run it in the browser. And actually, you can now even run it on the fly. You can get restrict mode checking of your program on the fly if you want to, thanks to some AMD magic. The restrict mode checker is a plugin to this. There are others too. Assert that we talked about. That's what will give you nice, good assertions. Bitwiser Watcher, a yielder, which transforms your yield style code to normal code. Time for me to wrap up. If you want to use restrict, go to restrictmode.org/try. Download JSShaper, put it in your toolchain. If you don't want to run it each and every time you run your program, because perhaps you don't like the idea of having a toolchain or slowing down your toolchain, at least you can run it before you're executing your tests. It doesn't really cost you anything, but it might help you expose something. If it matches or doesn't match your subset, let me know. I'm really interested in hearing that. There's no lock-in. You can just remove the use restrict directive. No one needs to know that you went there in the first place, but because it's just a subset. It's still just JavaScript. To wrap up this whole idea of easier to reason about, so choose your subset. Consider the pros and cons of different subsets. Consider pros and cons of different constructs and style guides, and choose your together with your team if you're on a team. Definitely consider using tools to help verifying those, such as JSHint or restrict mode or whatever it is. Consider this idea of sprinkling assertions in your code. It might be a good thing. You might like it, so try it. Absolutely prioritize getting your APIs right. Challenge your assumptions, especially so when you are in debugging mode, if you don't have a rubber duck handy. And remember that reading code is a skill, so keep practicing it and learn from others. And have fun. So this was a story about how assumption met a magic hat, and I'm Olov Lassus. Thank you. I'm not sure whether we have time for a question. One question.
I got two, so let's see. What are you thinking about checking indexes on arrays using some kind of this transformation as well?
Yeah, so you could do that. Another question I often get is, should we change truthiness? Should we check that? So in terms of truthiness, now that's very, very deeply buried in the language. It's hard to do. Indexing, sure, we could do that. We could override the index operator and create a dunder index function. I'm not sure how much that would give us, because in JS, it's common practice to reference a property that doesn't exist, say dot something, and check whether it's undefined. So that would be really surprising if that started crashing. I'm not sure how common practice it is actually to index an index in an array that doesn't exist and see whether it's undefined or not. But I think it's common enough that it will kind of, get people a bit wary about using this subset. Otherwise, I think it's a good idea. It could be an option. OK, thank you.